Here in the developed world, we have come to expect cheap and plentiful water supplies. We have built organizations and infrastructure to satisfy our needs, and with very few exceptions, water has been made readily available and affordable. But times are changing. Today, water supplies in many parts of the world are being stressed to their limits. Global freshwater consumption has more than doubled since World War II and is predicted to rise 25% by 2030. Environmental effects, increased per capita demand, population growth, potential climate change, pollution, drought, and waste are factors affecting availability and driving up prices. One view looks to privatization and free markets to improve water prices and availability. It holds that water is a commodity that should have its price and allocation primarily driven by the cost to provide it. Others strongly disagree with this approach and instead take the position that water is a human right and it must be provided at prices everyone can afford. They see water markets driving up prices to levels where developing countries can no longer afford necessary supplies. Some governments have turned to privatization in order to deal with certain inefficient, costly, and unreliable public water systems. Others are moving away from private operation after having experienced unacceptable results. With such strong and divergent opinions in play, it seems clear that both the government and private sector will be heavily involved in world water markets for the foreseeable future. The $500 billion global water market is growing fast. Investors and corporations are paying attention and wading in where they see profit potential. Drinking water distribution, waste treatment, agriculture, and desalination are major sectors receiving heightened focus. Some say that water is the new oil, and that in the 21st century, the increasing value of global water supplies will result in water becoming even more of a market good. Others say that water is unique and too essential to ever be just a commodity. Wherever you stand on these issues, three things are true. The demand for fresh water is rising, costs have been going up, and new supplies are getting harder to find. So where can water leaders find new and sustainable fresh water supplies? Here are a few of the approaches being taken. Recent technological improvements have lowered the cost of desalinated water. More efficient pumping and membrane designs are reducing associated electricity expenses to the very competitive 50 cents per 1,000 gallons range for a large capacity plant. Since more than 90% of the Earth's water is in its seas and oceans, efficient, widespread desalination could mean massive new freshwater supplies. In some cases, new water supplies aren't really new at all. They're captured supplies that would have otherwise been lost. If water resources can't be used immediately, they're often lost downstream, or are used by others better prepared to take advantage of them. But if a region can develop reservoir or other storage infrastructure that captures and stores unused water, the net effect is an increase in their overall supplies. The treatment and reuse of existing water resources is one of the most promising areas for effectively expanding overall supplies. Processed wastewater can be directed toward specific purposes, such as irrigation, power plant cooling, and aquifer recharge, freeing up freshwater supplies that would otherwise be used. If a region can function effectively while consuming 25% less water, and there is a method of storing and retrieving the water they've saved, then they have effectively increased their supplies by 33%. Although technically not a source of new water, the result is the same. This is one of the reasons conservation has a significant role to play in strategies to acquire additional water resources. Additional local water supplies may be available in the form of tributaries feeding larger rivers and untapped groundwater reservoirs. Identifying, securing, and transporting new supplies like these may involve purchasing or leasing water rights and the building of water collection and transportation infrastructure. Clouds bring the precipitation we rely on for most of our freshwater supplies. The problem is that weather is uncontrollable. Or is it? Over the past 60 years, efforts to increase precipitation through cloud seeding have been ongoing. Results have been mixed, and the practice remains controversial, but some positive results have been recorded. Today's water leaders operate with a heightened focus on environmental concerns. Issues of sustainability, ecological impact, and conservation all play a role in current dialogue and decision-making. Sustainability, in reference to regional water supplies, means more than just an expectation that adequate deliveries can be maintained over time. It means that natural, social, and economic factors must all be considered and brought into balance when developing and implementing plans for current and future freshwater resources. The construction and operation of vast, complex water delivery systems entail environmental concerns. But many negative impacts can be mitigated or even eliminated if proper design, maintenance, and operational methods are employed. The key is to investigate and consider environmental effects early in the planning and development stages so that impacts can be minimized. In addition, cooperative intergovernmental agreements can provide offsetting, habitat creation, and species protection. An example of this type of proactive effort is the Lower Colorado River Multi-Species Conservation Program. It is designed to protect endangered and threatened species while conserving or creating thousands of acres of riparian habitat. Water utilities also have a significant role to play in water conservation. In addition to programs directed toward water customers, water providers can look to their own facilities and procedures to reduce waste and improve efficiencies. Focus areas include identifying and repairing leaks, calibrating, repairing, or replacing malfunctioning metering equipment, and auditing large volume users. Electric power is another area of economic and environmental focus. Hydropower is renewable and widely available in the global marketplace. In terms of reliability, cost, and efficiency, hydropower is superior to solar, wind, geothermal, and biomass. It is one of the top forms of renewable energy worldwide and second only to fossil fuel in total global energy production. Hydropower is among the cleanest sources of power generation known. It produces no toxic air emissions and no solid or liquid wastes. It is also one of the cheapest forms of energy production. Compared with nuclear or coal, hydro plants typically cost less than a third as much per kilowatt hour for operations and maintenance. Hydro also represents a great opportunity for future development, since only a small fraction of worldwide hydropower generation capacity has been developed to date. The United States is responsible for about 12% of the world's hydropower. Since 1970, American hydropower production has grown by roughly 45%, and today it accounts for slightly less than 10% of our total U.S. electrical power generation. Federally owned plants account for less than 7%